Hello students, how are you? Hope you are all fine. Let us go through our topic, Lewis formula for molecules. For this we have to follow some steps to write Lewis formula. Here I will explain all these steps by using an example phosphoric acid. So in the first step we have to write symmetrical skeleton for this molecule. For this first we have to identify the central atom which is having least electronegativity except hydrogen. Even though hydrogen has same electronegativity as phosphorus, that is 2.1 electronegativity for hydrogen and 2.1 electronegativity for phosphorus. Even though they have same electronegativity, we cannot choose hydrogen as a central atom. So first we have to choose phosphorus as the central atom, and next how can we write oxygen atoms around this phosphorus? Here these oxygen, ozone, peroxide, superoxides, only oxygen atoms bond with each other, but in other molecules no two oxygen atoms bond with each other. So we have to write oxygen atoms around phosphorus as like this. And next hydrogen actually bond to this oxygen atom, not to central atom in oxyacids. So we have to write hydrogen here. This is the skeletal structure. And next step, we have to count the number of valence electrons of each atom and add them. So for this phosphoric acid H3PO4, we have to count the number of valence electrons. For hydrogen, one valence electron is there, and here 3 hydrogens are there, so we have to write into 3, plus for phosphorus, fifth group element. So phosphorus is fifth group element, so 5 valence electrons are there and only one phosphorus is there, so into 1. And for oxygen, 6 valence electrons are there. Here 4 oxygens are there, so we have to write into 4. So we can get 3 plus 5 plus 24. Total 32 valence electrons are there. We have to indicate this number as A. This is the total number of valence electrons of this molecule. In step 3, add the number of electrons needed by each atom to get noble gas configuration in its valency shell. That means every atom needs 8 electrons in its valency shell to get noble gas configuration, except hydrogen. Hydrogen needs 2 electrons to get noble gas configuration, that is helium gas configuration. So we have to write 2 electrons for hydrogen, and for 3 hydrogens we have to write 2 into 3, plus for phosphorus 8 electrons, only one phosphorus is there, so we have to write into 1, plus for oxygen also need 8 electrons in its valency shell. For 4 oxygens we have to write into 4, so we can get 6 plus 8 plus 32, total 46 electrons. These electrons are indicated by capital N. N is the total number of electrons needed by all atoms to get noble gas configuration in its valency shell. Step 4, we have to calculate total number of electrons shared. We can calculate number of shared pair of electrons. S is equal to, here N is 46. N is 46 minus total number of valence electrons are 32. So we can get 14 electrons. 14 electrons are shared pair of electrons. So we can write shared pair of electrons in skeletal structure of phosphoric acid. Here hydrogen, oxygen, phosphorus, oxygen, hydrogen, oxygen and hydrogen. This is the skeletal structure. We have to write shared pair of electrons in between these atoms. We have to write 2 electrons between 2 atoms like this for one bond. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 are shared pair of electrons here. And next we have to write a lone pair of electrons on the atoms which are present around the central atom first and next on the central atom. For oxygen it needed 8 electrons to satisfy octet rule. So 4 electrons are there, 5, 6, 7, 8. Here we have to use another color to recognize lone pair of electrons. 4. Here 4 electrons are there, remaining 4. Here also for oxygen 4 electrons are there, we have to write another 4 electrons. And next for oxygen 2 are there, we have to write 6 electrons here. All these oxygen atoms get 8 electrons around it. So these all follow octet rule. And for phosphorus also 8 electrons are there. It can also follow octet rule. And next, lone pair of electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 lone pair of electrons are there. We can also calculate lone pair of electrons by subtracting shared pair of electrons from number of total valency electrons. Here lone pair of electrons, we can get them by subtracting shared pair of electrons from total number of valence electrons. Total number of valence electrons are 32. We can subtract shared pair of electrons. Here shared pair of electrons are 14. We can get 18 lone pair of electrons. Here also, when we count down all these electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 lone pair of electrons are there. Now we can turn shared pair of electrons into bonds like this and calculate the formal charge for every atom. We can get -1 charge for this oxygen and +1 charge for phosphorus and 0 for these oxygen atoms and hydrogen atoms. And next, if we can turn these lone pair electrons into bond pair electrons and calculate the formal charge, we can get 0 formal charge on each atom. Here these are the shared pair of electrons and these are lone pair electrons. And when we can turn these lone pair electrons into bond pair electrons and calculate the formal charge, we can get 0 charge on every atom. If the formal charge on every atom is 0, that structure will be the most stable structure. So we can get the most stable structure as this structure is the most stable structure for phosphoric acid. When compared to this structure has formal charges 0 on every atom. So it is the most stable structure. Thanks for watching. If you like this video, please like, share and subscribe my channel.